Welcome to the Sports Tech HQ podcast, the show where we explore the latest innovations transforming the sports and tech industries. I'm Jeff Hintz, and today we have a truly special episode focused on the exciting intersection of sports and engineering. Joining us are two exceptional guests from Purdue University's Ray Ewry Sports Engineering Center, Dr. Jan-Anders Mansson, the executive director and a distinguished professor of materials and chemical engineering, and Patrick Cavanaugh, a research engineer. Gentlemen, thank you for joining us here today.
Pleasure.
Thanks for having us.
And before we get started, can you tell us what is RESEC? What is the Ray Ewry Sports Engineering Center, and what is it all about, and maybe a little bit of why it's named Ray Ewry?
So first of all, we start with why the name Ray Ewry Sports Engineering Center.
Sure.
Ray Ewry has an exceptional background. For more than 100 years ago, he started Purdue, had polio, came in wheelchair into Purdue as a student, decided to get out of that by training himself, and to the level that he got to be enormously strong in jumping. And to the level that he also won gold medals in triple long jump, and high jump. And was of course, and this was in Valid Olympics, was not in any Paralympics.
Okay.
So an exceptional student, and it was so suitable to name the center after him. And he had the most gold medal in any Olympics until Michael Phelps, 100 years ago. After that
gives me so wheelchair bound
when he came in,
trains and wins gold medals.
Yep.
In multiple events at the Olympics.
Yeah.
Wow.
It's a fantastic story. And an engaging story for many.
Okay. And then RESEC, what is it all about?
So I can talk about the research part. Maybe you talk about the teaching part of it.
Sure.
So if the RESEC is, let's say, how can we collect all the fantastic competencies we have at the university into one focus area and be a magnet for things that can be used in sport? And now by teaching students, doing research activity, and also industrial engagement. And RESEC is a fantastic melting pot of competences that we have at the university. And why is that important? Yes, a university, we say sport in general, it's very multidisciplinary. Technology change, and we can change the lab we work with. So we are kind of a magnet for new technologies that are coming into the sport field. So that is where we say research is powerful for us to be at the university. Then there's a teaching part of it. Maybe you can elaborate on that.
And I'd also like to add, Ray Ewry was a Lafayette native and mechanical engineering graduate of Purdue. So the engineering really runs deep through that namesake. But yeah, as Professor was saying, we have these three components: the industry engagement, the research, and the education. What we're really trying to do is figure out where's the unique value of the intersection of all three of those components. Because I think you can look at other programs and even other groups, and they can address one of those things, but very few places have all three of those things bringing them together. So how do we, bring in students who are coming maybe just for an undergraduate or a graduate degree and connect them with the companies that are interested in working with Purdue in a more formal sense, create talent pipelines, and how can we connect that with the other research that we're doing to create experiential learning opportunities for everyone involved.
Right. Okay. And give maybe the listeners a sense of Purdue University and kind of the accolades that Purdue has. A lot of people hear Purdue, it's a Big Ten university, but it's an incredible institution, particularly around engineering. So how do you sell Purdue? Just from an overall school, where does it rank?
Let's base ranking, and ranking is depending on many factors. I can explain it from my point of view. I'm old enough, so I've been at a number of universities, both in the United States and in Europe. And I would say it's exceptionally good university, both with the competencies that is there, but it's also extremely well-run university. So coming here, I've been very impressed by that. And the collegial spirit at the university is fantastic. So it's all that brings it up to a good position, I would say, in the academic world.
Okay.
Yeah, and then on the stats side of things, I know universities love to tout their rankings and whatever various, U.S. News or whatever rankings agency, but Purdue has consistently ranked in the top 10 for public engineering universities, both at like the college level, but then each individual discipline. So they bring a lot of national recognition from a kind of collective engineering standpoint, but then every individual engineering discipline and a lot of other, human sciences, business, like it's brings a lot of very high ranked, very well regarded programs to the table, right, all that can be applied to sports.
It's a powerhouse program. It's a powerhouse school globally.
Absolutely.
It's great to have it here in our great state of Indiana. And, what I'm hearing is you're at a powerhouse university that's globally ranked, particularly for engineering. And you're also really on the cutting edge of kind of these new technologies that are coming out for sports. And you're providing research to those projects. You're seeing some of the very first things, that might have iterations downstream, but you're seeing things when they first start, and your students get to work on those, which is great. So let's pivot to students a little bit and maybe just talk about the curriculum that helps support RESEC, the skills, knowledge, and needed to excel. And it's an evolving field. I mean, sports tech, when we talk about sports tech, a lot of people, when we first started, it was just gaming, esports, and it's so broad and massive, and it gets into fitness tech and health tech, materials, which is your world. And so maybe talk a little bit about the curriculum and how you set students up for success and connecting them.
Yeah, sure. So I think when you think about a collegiate education, or especially in engineering, a lot of times people talk about the T model, where you have this really, shallow kind of base, and then you pick one area to go really deep into it. So like in mechanical engineering, chemical engineering, you really go deep into the fundamentals of that discipline. In sports engineering, we go even wider. And because it's so wide, we can't go as deep into any one field. So really what we've tried to focus on is how do we identify the relevant areas that are going to be useful for sports problems and sports engineering, give them an exposure to, see these are the tools that are out there to be able to solve those problems, but then really focus on, the problem solving strategy of bringing those tools together in new ways to be able to solve the problems that have presented themselves. So we're not going to get students can choose to specialize in any one of these disciplines. It exists currently as an interdisciplinary program. So they have flexibility to choose, areas to suit their interest. But, a lot of the stuff that I focus on in my teaching and that's brought to the program is, solving these problems through hands-on experiential learning. So giving them the opportunity to identify a problem, whether it's something they've come up with or something they're partnering with a group on campus or a company, to really practice that problem solving strategy in a real world application. Because, you can teach someone how to solve problems, but they're not really going to learn how to do it until they do it themselves, because every problem is going to be a little bit different. And, just doing it over and over again, practicing, whether it's a little problem or a big problem, that's going to be the best way that they're going to learn how to really take those kind of that exposure to the fundamentals and turn them into real world solutions.
Okay, great. And so let's look ahead a little bit. And how do you envision sports engineering education adapting to the rapid advancements and what we've seen? You think about AI and the proliferation of AI. You think about materials engineering and some of the new material that we're seeing, like graphene and others. How do you envision kind of your program staying on the edge?
So that's a good question. For that, it's actually a trick when you are in the sport field. It's not a discipline by itself. So the power of that is to be able to be adaptable, to be able to adapt to new technology that moves somewhere in a university. How can we embrace that, have it as part of our education? So, for instance, we both have a background work with aerospace. It takes 10, 15 years to adapt the technology to be used. Then they use it for 20.
In aerospace.
In aerospace.
Right.
If you take automotive, for aerospace is so, we say, safety and security driven. If you take automotive, it might be 7, 8 years to adapt the technology. Using half. Even half of that is sport.
Okay.
So now it's got to rotate technology very quick, where it's performance driven. Even faster than that is consumer electronics, and fastest of all is the thing related to fashion. Yeah. But if you see fashion, consumer electronic, and sport, it grows together today. When you buy stuff, the market out there is combined wearables together with a good look of it and use in a sport or a life quality situation.
Right.
So that is a very good, at your university or at some area like in there, you are at the beginning of the technology evolving, but we are very quick to use it. Aerospace, for very good reason, have to be more careful.
Sure.
So that is an advantage to be at the university. A company can't have all competences in-house. They have to depend on outside competences.
And that's where you come in.
That's where we come in.
Okay, perfect. Okay, so let's talk about what you're doing and what you've set up at RESEC. And exciting that we were able to announce a partnership with the two of you in the program here during the Indy Classic at the end of 2024. And excited about what that's going to do for our ecosystem here in the state of Indiana. But can you talk a little bit about the uniqueness of the program? Does this exist? Are there any other universities that are doing what you're doing with sports engineering and particularly sports tech, materials engineering around sports that you're aware of in the United States?
So when you look to who is active, which university are active in sports science or sport engineering, in the rest of the world, there is quite a bit of initiative. In United States, there is not an organized drive towards sport engineering as a master program as we have and a center for it. There's many universities do sport research, but not as a focus both on teaching and on research area of it. That is where we come in and are unique. And I should say, yeah, we can brag about we are good in engineering, but also how do you market this?
Sure.
And there we are there we have nothing to brag about. This is why the collaboration with SportTech HQ is fantastically powerful for us.
Sure.
You are out there, you have your sensing what's happening at different places, and in the interaction with you, they stimulate a lot of our activity.
Great. Yep. We're excited about that partnership. So let's talk about some of the projects that you've worked on previously, or some of the active projects that you may be working on now with your students. You mentioned master's students. This is a master's level program at Purdue, and you have some PhD students as well that are tied to this, right? Talk about some of the projects that are coming through the program now.
Sure. Yeah. So I think to get a little bit more into the details of like the structure of who's involved, like at university, you have PhD researchers. Those are people, dedicating a lot of time and energy to some fundamental topic. And so we found some really cool sports applications where they can, write their thesis on a topic that's going to contribute to an outcome there. We have 3 PhD students working on projects right now in a variety of areas. One of them is actually the project how I got involved in equipment. It's called homologation. I don't know if the audience is going to be familiar with that term.
Go ahead, explain it.
Okay, so it's the process of kind of standardizing the performance of a piece of equipment in, I guess, a competitive setting. I mean, you're definitely the expert in homologation.
Yeah, in order to ensure that you have a level playing field in any competition, Olympics or World Championship, then you have to make sure it's not the equipment that is the difference. Or it's the worst that can happen is that he won or she won due to the equipment. No, it's the skill of the person that should be first. Equipment should be in the shadow of that, but it has to be the same for everyone.
Right, with some standardization and limitation
of it.
We're going to get into some of that here in a few about what you worked on it. Me coming from the golf world, I think about what's happened in the golf space from an equipment standpoint. It might be something that maybe got a little out of hand, with just the golf ball and how long the golf ball goes now and how long it flies, how far it flies now than what it used to. What is it? The coefficient of restitution, off the club face, it's just like the almost
coefficient in the air,
almost like the springboard effect off of the club face itself. And it's something I know the USJ and others are looking heavily into, because what you said is exactly right. It should be the athlete, that wins, not the equipment that wins. Okay, so more of the current projects?
Right, so that project actually led into a study on cycling drivetrain efficiency. So we're working with a company actually here in Indianapolis on looking into some more fundamental science of the lubricants that are used within a chain system on a bicycle. A lot of people don't realize how complicated that is, but there's like a couple hundred moving parts just in that chain assembly. So a lot of interfaces that need to be, lubricated properly and contribute to the wear. So that's one. That's what I've been primarily involved in. But then we have another graduate student looking at the term feel and control in tennis rackets. So how do we design to the needs of the athlete and how they're perceiving the performance of the equipment rather than just like the mechanical parameters of equipment performance? So it's really easy to measure stiffness, weight, coefficient of restitution. Like you can measure those things really well, but that doesn't always impact, or that doesn't always result in higher performance from the player, because we as humans have weird ways of perceiving things. And in order to really build that interface between the human and the equipment, we have to understand how the human is going to perceive all of those mechanical parameters. So like designing for that interface rather than designing for the purely mechanical side of the equipment.
Okay.
And then we have another PhD student working on space and time in football, American soccer.
Yeah.
So he's a big soccer nut, really smart with numbers, really big on data science backgrounds. Looking at, how do we quantify how athletes visualize and perceive space and time in soccer? That's the application, but can be applied to all team sports.
Sure.
So we put a lot of emphasis on what's going on around the ball, because that's, typically what viewers care about. Right. But there's, pitch is 100 meters wide or 100 meters long and 50 meters wide. There's so much activity going on all around the pitch at any given point that's setting up plays that are 10, 15, 30 seconds away. So to figure out how do we quantify the value of those players and how they move around and how that contributes to the overall game performance. So those are like the big, big outcomes, big topics, looking into them very deeply. Takes a lot of time, takes a lot of experience and expertise to go into to find those answers.
Sure. If I may ask one point to that, you mentioned AI. This is where this kind of technology came in. Can we use this in a way that we can use it as predicting tool?
Right.
And going into machine learning with that, and that's where that project is heading.
Yeah, so that was one of my questions with the emerging areas. So AI clearly is an emerging area for you all and how it interacts with engineering.
Absolutely.
Yeah. This is good. So in theory, just for our listeners, think about the work that a center does at a university is, let's say, enter X number company, whatever company the name is, and they want more research on feel and control in a tennis racket or in a golf club or whatever. They come to Purdue University, Ray Ewry Sports Engineering Center and say, we have a problem, or we need more data. We want more research done on this particular issue. That's where you come into play, and you work with your PhD student, and it's really a project for that student along with the staff. Is that right?
Yeah.
Okay. Perfect.
Yeah. And it's really interesting. And as I've worked in the university, I've really gotten to know the different level, I call them execution methods for getting projects done. You have these like long-term fundamental outcomes that PhD researchers are working on, but you also have a very large number of like short implementation projects that may go 4 months, a semester, or a year, where you can bring in students of different levels into like, hey, we have this problem. Someone wants something looked at. It's kind of difficult to balance the time of a PhD student. So you have a lot more resources available for like students to come in and get experience on a project solving a smaller scale problem for a shorter amount of time. Because a lot of times you don't need a PhD level research or researcher for some of the projects or problems that come to us. And at that point, you just get the more people you get working together, the more productive your outcomes are going to be. And we have to really meet those projects at the level that they're looking for.
Sure.
So that's a good example of a research project. But that research project, over the 2 years, we've had something like, I would say, 10 undergraduate working on the project.
I see.
They do that as part of their study. So yes, there's research, but there's an educational dimension to it as well. And we can say one thing: when you come to sport project, you attract easily student, but also very good student, which is fantastically inspiring.
Right.
But don't forget, when we deal with a sport, it's sometimes the student or the experts. If you deal with an airplane engine, it's definitely the professor that is the expert.
Sure.
So they come with influence. Oh, have you thought about that? Shouldn't we do that? That gives a stimulating situation for the students. They're part of it much more than they are in another project. Sorry, I interrupted you.
Yeah, no, I mean, it's a really good outcome and it's a really good resource for the students. to be able to bring their own expertise into some of these problems. Like it's pretty easy to go into the university and say, oh, we have a problem in tennis or a problem in cycling.
Sure.
Well, there's the cycling club, there's the tennis club on campus. And we can just say, hey, are any of you guys interested in working on a project that we have? And you get a ton of people with a ton of experience that,
Sure.
you know, I don't have, or that, you know, the current members of the team don't have. So, you know, they'll come and bring in not only their technical competence based on their engineering background, but then the practical competence of having dealt with the nuances of each one of those sports, you know, often for a decade or better part of a decade as they've been growing up in that sport.
Sure. Yeah, I remember speaking at your class. I did not lecture because, you know, but I was a guest speaker in your class. And if you remember, I asked everybody to stand up if they played high school sports or youth sports. And, you know, I had all these questions about sports. How have you interacted with sports? And soon enough, we had the whole room standing up. You know, it might have been 100 students in the room or so. And it just goes to show how sport is so important in people's lives. And if they can turn that, you know, fun thing they've done in their youth sports career or whatever, and turn it into an application that maybe a future job or whatever, that if you do something that you really enjoy, that you get up every day and you kick the covers off because you love sports, but now you can be involved with a major brand doing research for them and innovation. It's powerful.
Yeah.
I like what you say there. It's a good example how I ended up in it.
Yes, but let's get into your background. Yes, let's do that.
You get so inspired by it, and it can drive both. The good thing, it drives both your head and your heart.
Right.
At the same time.
Love it.
That when you get that, you get power.
Okay, so let's talk about your background, where you're from. Clearly, there's an accent. And what is the accent? Where are you from? And then where have you spent a lot of your time in your career before you came here to Indiana?
Fortunately, I cannot hide my Swedish.
That's okay. We love it. Yeah, Sweden.
And so there I got my PhD, worked in industry also some year. Then professor at University of Washington in Seattle in composite material, carbon fiber stuff. And all my research was with Boeing at that time.
Okay.
Then moving to Lausanne, Switzerland. Lausanne is where the International Olympic Committee and many sports federations have their home. But was in composite, but it didn't take a long time until I started to get into the sport field there. Started to work more and more with the Olympic Committee, and also created an sport management education, which I was part of heading until I moved to Purdue. And during that time, I worked with research in different sport equipment, but also with America's Cup for 10 years. R&D related to the America's Cup boat, the Swiss boat Alinghi, which happened to win 2 times.
Wow.
And that was powerful. That was really powerful. And following that work with sailing in America's Cup, I was asked if I could help with the problem I had with the swimsuit in 2008, 2009, where we have free fall of all world records due to the material used in the suits. And how can we start to homologate, certify the material that can be used and the construction of the swimsuit? And that was, of course, it hit both my head and my heart. And from there on, it's have just been going on and been growing on me.
And you said that was a moment that changed your life.
I would say it did, for it totally changed my direction of my research as well. And I saw how inspiring it was. Of course, the advantage, you were on the older side, you had a lot of experience with you, and to implement that in the sport field, very, very attractive, very stimulating. And you saw also the student attraction to it.
Yeah, right. Okay, so we're going to come back to a couple examples. Why don't you give us your background, Patrick?
Yeah, so I'm just 2 years out of engineering education out of Purdue, did aerospace engineering. So, you know, graduated in May 2023. Loved it. You know, Purdue's a great school. I had some industry experience in internships. You know, it was all right. Was able to start in Professor Mansson's lab as an undergraduate researcher on the trainer homologation project that we talked a little bit about before.
Bicycle trainer.
Yep, bicycle trainers. And then worked very closely with the PhD student that's still working on that project and still do. It's Teal Dowd. I'll give him a really good shout out. He's done a ton of work on that. But so that's how I got involved, you know, in the program initially. And, you know, where I am today, I actually had decided to stay at Purdue after graduating because I was pursuing a professional triathlon. through my like senior year, and then for a year after graduation. And Professor Mansson was very generous, saying that, like, oh yeah, you mean you can work here, you can have flexible hours, train as much as you need, get involved in the things that you see fit. So that was kind of the arrangement that we had over the last year. Unfortunately, professional sports in any sport is very, very demanding, very, we'll call it brutal or ruthless.
Yeah.
And I have a ton of respect for the people that are able to make it. Unfortunately, I wasn't able to make it. So now I've moved into a full-time capacity with the center, focusing on that intersection between our educational programs and research. I like to use the word experiential learning, figuring out how to create those opportunities for the students, both in the master's program or at the undergraduate level, and connect that with the work that's being done at the PhD research level.
Got it. Okay, so a little show and tell here. You brought a few things. Can we talk about a couple of them?
Yeah.
Maybe bring out a few of the toys for those that are watching. For those that are listening, we'll do a really good job of describing what we have here. But where do we want to start? Do you want to start in tennis, or do you want to start in swimming? Why don't we start with the moment that changed your life, the course?
So what happened in Beijing Olympic 2008?
The Beijing Olympics, 2008. Yeah.
I saw that there was a record fall that was enormous. But that was just the beginning. Then 1 year later was the World Championship in Rome.
Okay.
And I was 42 world records in 1 week.
42 world records in 1 week.
So now we had a tremendous...
You had a problem.
A problem, yeah. And now it was to the level that it was so bad, so they didn't say how many gold medals a country or a person had. So many gold medals that Speedo have, so many arena, and so many, and that's
the equipment. Goes back to the equipment.
The equipment.
You have an example? Do you want
to? Yeah. Got one right here.
So this is the one that was really the one that was coming out. That was the swimsuit by Speedo, what's it called? The laser racer. And what was unique with that, they started to have plastic cover, polyurethane covers.
Okay.
Which had, of course, a surface effect, but also it could help to trap water.
I see.
Well, trap air so water didn't come in.
Yeah. Trying to get a sense for kind of what we're working with here. Not exactly your typical swimsuit material.
No. I mean, it feels, very plasticky here.
Exactly. Yeah. And then the next step, of course, why don't we put the same over the whole suit? And that was 2009, and the record was just... And at that time, it was coming out of the America's Cup, and... they said, if you can deal with a sailboat, you're sure you can deal with our swimsuit. Help us to change the rules.
Wow. So what did you do? So you helped them create some limitations for the manufacturers on how much of that material could be
exactly permeability here.
The permeability.
So how much air can go through it. Here, now, zero can go through. So now we have all suits or there is no plastic cover on it.
That's right.
But I have to be permeability of 80 liter per meter square in second. That's the value.
Okay.
And we develop equipment to measure that.
Okay.
And then the certain construction rules, especially for men, went from full bodysuit to just a jammer.
That's right.
But for women, it was still, of course, full bodysuit. But now we have to set rules for the material. And we took it back to the level of the record evolution. But the problem was a little bit already done. Huh? Now you have world record out there, and we changed the rule backwards.
Yeah.
Now we had record vacuum of 5 to 10 years, which is never good for a sport. And that is when I say a federation have to be proactive on the rules, not reactive. If you're reactive, you still sit with the problem.
Okay.
So that's where the federations I work with is always about what technology is around the corner, what's up, what can we do?
Right. Okay, so that's swimming.
Yeah.
We have a tennis racket, I believe. This is one, when I first met you, Dr. Mansson, Dr. Mansson's a humble man, but this tennis racket's pretty important. Tell us a little bit about who used this tennis racket and then the work that you did on this.
So actually, this is one of the racket of Roger Federer. Mm-hmm. Being in Switzerland, of course, you have to work with Roger Federer.
Yeah.
And his racket is customized for him, of course.
Sure.
But all the other features is similar to what we're used to. And all what is customized is to get the better feel and control.
Mm-hmm.
And we have been so focused on designing equipment after the lightest and the stiffest.
Mm-hmm.
Whatever it is, lighter it is, stiffer it is, the better it is.
Okay.
But that's not true. Now the material, rackets, bicycles, skis, they get so light and so stiff, so they are nervous.
Mm-hmm.
And that nervousness is not good for the perception. So now how can, and a material that is really good for feel and control is wood.
So when you say nervous, you mean that it's picking up the slightest movement.
Yeah.
You know, translating that movement from that player into the racket because they're so light now. Okay.
So you're hit with the ball here and you feel a vibration.
Sure.
And that you have to damp out. Wood do it very well, but wood is too heavy.
Sure.
So now how can we create composite material that have this damping characteristics, but still is stiff, still is light?
Mm-hmm.
And that is a research area we're working on.
Wow, that's amazing. And that's the Feel and Control project.
Mm-hmm.
Yeah.
Students have been working on.
Can I show one more thing?
Sure. Yeah, let's do it.
This as well. So this is something that we had a team of undergraduate students working on last year in conjunction with the PhD research going on this. So, you know, I love when you talk about like showing, not just telling.
That's right.
This is kind of
show it to the camera so we can.
So, you know, it's not, you know, visually striking, but a team of about 5 or 6 undergrads over the course of 3 months put together this measurement device that goes into the butt end of a racket. I don't think it works with this one.
Probably not, but this is where it goes.
Yep.
Here.
So a little bit of a different style, different interface,
Sure.
but it'll actually measure some of those characteristics, not quite as, you know, high resolution as a bench stand,
Sure.
but give you some kind of insights as to what some of those metrics might be as you're actually playing with them in the field. So this was you know, just one of those examples of bringing in students to be able to work on, get experience in a really exciting application. You know, that team was composed of some tennis players, some people that didn't have tennis backgrounds, but had other stuff to bring to the table. And, you know, we really, really enjoyed working with them to get this thing made. So we're really, really excited with that. And we look for, you know, what ways can we replicate that in a whole bunch of different areas, whether it's working with a company or working on one of the other projects that we have going on.
Incredible stuff. So one last question here, and you think about the future. So think about 5-10 years down the road.
Mm-hmm.
Where do you see the role of RESEC and maybe particularly sports technology in the field of sports in general? How do you see the growth? Do you see it growing? If so, how much? And, you know, that intersection of research and engineering behind equipment and athletes, where, you know, fast forward 5-10 years, what would you like to see?
I can see where it's moving very rapidly now is anything related to fan experience.
Mm-hmm.
How do we get more information from the racket or from the player that the fan can digest and use his thoughts for? I think that's a direction it's going. When it's come to new material, that's more a constant evolution. I don't see any big steps in that at the moment.
Mm-hmm.
But how we gather information from the athlete and for their equipment, I think that's a movement that goes on very rapid right now. And with all then related to AI and so on, that will accelerate the whole thing.
Mm-hmm.
Amazing.
Yeah.
But once, as I said before, why is it good to be a university? If just of a sudden I say we are good on this, but this technology got to be important. Yeah, we have experts at the university. If we work with them, then
That's right.
and that is the power of this. We say combined competences.
Sure.
University.
Adaptability.
Adaptability.
So Purdue, you're the Boilermakers, but you're also future makers. You're making the future of sports technology. You're making the future of your students that are going through your program and getting them connected to the industry. So thank you for what you do. Yeah. That's Jan-Anders Mansson and Patrick Cavanaugh from the Ray Ewry Sports Engineering Center at Purdue University. Thanks so much for joining us. And to our listeners, thank you for tuning in to this episode of Sports Tech HQ. If you enjoyed this conversation, please subscribe to our podcast and leave us a review. And remember, stay tuned for our next episode where we'll explore another exciting innovation in the world of sports tech.